Imagine a tool that doesn't just, guess your next line of code, but actually builds the whole app while you watch. Let's explore why.
Yeah.
Welcome to today's deep dive. We are examining a really comprehensive guide on mastering Claude Code.
It's a huge topic.
Right. Our mission today is to demystify this incredibly powerful tool for you. We want to move you past, feeling intimidated by its features. By the end, you'll make it a reliable teammate in your daily workflow.
It's a fundamental shift in programming, really.
Yeah.
We are moving away from writing every single line manually. We're stepping into a space where you manage automated systems instead.
Exactly. So we have a very clear roadmap for you today. First, we'll start with what makes this different from standard tools.
Then we look at how to properly onboard it,
Yeah. And we'll explore the secret to strict prompt discipline.
plus managing its memory limits effectively.
Right. And finally, we'll dive into automating your most repetitive workflows.
It's a packed journey. The concepts build on each other heavily, so yeah.
So before we can use this tool effectively, we have to understand fundamentally what it is. How does it actually differ from the tools we already use?
Well, we need to contrast it with tools like GitHub Copilot. Copilot is essentially a highly advanced autocomplete tool.
Right.
It suggests the next line while you're actively typing. It definitely helps you write code much faster, but you are still deciding exactly what happens next.
It's the difference between a smart dictionary suggesting a word and, a ghostwriter drafting the entire chapter.
That's close, but even a ghostwriter needs a detailed outline. Claude Code operates at a much higher level. We classify it as a coding agent.
Let me quickly define that for you. A coding agent is an AI that plans and executes complex tasks independently.
Yes. It doesn't just predict the next word. It runs a continuous feedback loop. It reads an entire project to understand the architecture.
Wow.
Then it creates a detailed step-by-step plan, and it edits multiple files simultaneously.
Just all at once.
Yeah, and it can even run terminal commands and execute test suites.
Wait, so it evaluates the output of those tests?
Right, and it course corrects if a test fails. It handles the entire task from start to finish.
That's wild.
It also isn't trapped inside a browser window. It lives where you actually work. You can run it in the CLI for macOS, Linux, and Windows.
So it has direct access to your local file system. That feels incredibly powerful.
It changes everything. There's also a desktop app available that gives you a visual interface with built-in diffs.
Nice.
Or if you prefer your own editor, it has extensions. It integrates right into VS Code and JetBrains IDEs.
Oh, beat. Imagine it running multiple agents on different tasks at the very same time.
You can actually do that. You can have parallel sessions running constantly in the background.
That's crazy.
It works across different files without needing constant guidance. It just continuously pushes the project forward.
Okay, but how does it handle switching contexts without getting lost?
It reads the whole code base first to understand the architecture.
Because it acts like an independent agent, you don't just throw tasks at it. You have to onboard it like a new hire.
You absolutely must set it up for success first. Before you even write a prompt, you need a paid plan.
Right.
It requires either the Pro or Max tier.
Well, if I'm building a real product, I'd assume I just grab the max plan right away.
The best
and you want the best results immediately.
It's really tempting to just jump to the Max plan, but honestly, it's kind of a waste of money when you're just starting out.
Really?
Yeah, the source specifically advises starting with the Pro plan. You're going to make mistakes initially.
Oh, for sure.
You don't want to burn premium tokens while learning the system.
Right, so you only upgrade when you consistently hit those usage limits.
Exactly. Pro is plenty for testing workflows and finding your rhythm. So once you install it, you open your project terminal.
I have to admit, I still wrestle with prompt drift myself. I am constantly jumping into tasks way too fast.
That is the most common beginner mistake. People open the tool and immediately demand a new feature. You should actually do the exact opposite. Your very first prompt should be entirely about discovery.
Ah, so you want it to map the territory first.
Yes. Ask it to explain your codebase thoroughly. Tell it to describe the architecture and locate key files. Ask it how the major dependencies interact.
So let it build an internal mental model of the project.
Precisely. Once it understands the landscape, you establish the house rules.
Right.
The source highlights a specific file you need to create.
The CLUD.md file.
Yes. It acts as a persistent instruction document. The system quietly injects this file into the background prompt.
Oh, interesting.
It frames the AI's persona for that specific folder.
So you put your architecture notes and coding conventions in there.
You also add the specific commands used to run your project. And crucially, you explicitly state things it should avoid doing.
Right.
If it makes a structural mistake, you update that file immediately.
But you want to keep it under 100 lines, right?
Keep it concise. Too much text dilutes the system's attention span.
So what happens if you skip making a CLAUDE.md file?
You'll waste time repeating the exact same instructions every session.
Okay, so we got the agent onboarded and the house rules set. But talking to an agent requires a different language than a standard chatbot.
It really does. This separates casual users from the real professionals. It completely comes down to strict prompt discipline. Vague prompts will always generate vague, unusable results.
I imagine just asking it to, like, fix the bug is a recipe for disaster.
Oh, definitely.
You probably have to be incredibly prescriptive about the exact files and the exact definition of done.
You really do. You must define 4 specific elements every time.
Okay.
First, clearly define the actual task. Second, list the exact files involved.
Right.
Third, describe the expected outcome in detail. And finally, state exactly how to verify the result.
You also want to encourage Claude to ask follow-up questions, right?
Of course, let it clarify. A few questions early on will save hours of debugging later.
That makes sense.
It forces the model to check its own assumptions.
Then we have to pick the right underlying model. The guide focuses heavily on Sonnet 4.6 and Opus 4.6.
Yeah, Sonnet 4.6 is optimized for speed and token efficiency.
Yep.
It's your daily driver for bug fixes and standard features. It handles the bulk of the actual coding work.
But Opus 4.6 serves a very different purpose.
Opus has deeper neural pathways for complex logic routing. It's built for massive architectural decisions.
Wow.
It also supports a much larger context window. That helps it retain relationships across hundreds of interconnected files.
Using a weak model to save money is like buying cheap shoes. You replace them so often it costs more.
That's a great way to look at it. Cheaper models hallucinate more often.
Right.
You end up spending extra tokens just fixing their silly mistakes.
Let's talk about expanding the agent's reach. The source highlights MCP integrations. Model Context Protocol is a way for AI to securely connect to external tools.
It's an open standard that builds a secure bridge. It lets Claude reach completely outside your local environment. It can read your GitHub repositories natively. It can pull project specs from your Notion workspace.
Wait, it can even push automated updates directly into Slack.
Yeah. It transforms the agent into a cross-platform project manager.
Incredible.
But you have to manage those connections very carefully.
Can having too many MCP integrations slow you down?
Yes. Unused tools eat up your token limits quickly.
Placeholder.
Mm.
Mid-roll sponsor Read provided separately.
Welcome back to the deep dive. Once the tools are connected and the prompts are sharp, we get into the actual building phase.
This is the core build loop you'll use every single day.
Okay.
It's a simple process. Give a clear request, check the first version, review the output, ask the agent to improve it.
The source uses a Kanban project management app as an example.
It's a perfect test case. First, you outline your core features clearly.
Right.
You specify the design framework, like React and Tailwind. You list technical requirements, like using local storage for data.
If it's building a whole Kanban app, I wouldn't want it just writing code blindly. I'd demand to see the plan first.
You absolutely ask for the blueprint first. Tell it to explain which files it plans to change. Beat. It forces the model to articulate its logic before touching your code.
Once it builds the first pass, how do you verify it?
You use the built-in preview panel. It lets you interact with the local running interface immediately.
Oh, nice.
You don't have to guess if the code works. You see the real application.
But the first version is almost never perfect. You have to iterate visually.
Right. And you review it just like a user would. If the padding is completely wrong, you don't need to explain the DOM structure.
You just paste a screenshot of the broken UI directly into the chat.
Exactly. The vision model analyzes that screenshot spatially.
That's so cool.
It correlates the visual discrepancy with the Tailwind classes in the specific file. It maps the pixels back to the code automatically.
That feels like magic.
Right.
But you can also divide the labor using parallel workflows. You delegate the front-end UI to one subagent.
Right.
Then you give the back-end database logic to another subagent entirely.
It's highly efficient. You just keep each agent focused on one distinct domain. This prevents them from trying to edit the same file simultaneously.
I have a concern about this much autonomous action, though. How do you prevent it from breaking the app while you're not looking?
Good question.
If 2 agents are touching the same state manager, things could go sideways.
That's where your discipline comes in. You must always review the diff before merging anything.
Okay.
You instruct the agent to keep its requested changes very small. Small changes are easy to verify and easy to revert.
Right.
You treat every single round like a manual checkpoint.
Is it better to describe UI changes or show them?
Showing is faster. Just paste a screenshot of the issue.
Iterating visually sounds incredibly fast, but there's a physical limit to this process.
Very true.
Eventually, the AI's memory gets bloated and the logic starts to break down.
This is where beginners bleed time and money. It comes down to managing your context weight meticulously.
So what is actually creating all that hidden weight?
Every prompt and every file change gets appended to the context window.
Oh, wow.
It remembers its past mistakes and previous tool outputs. Beat. As the session grows, processing that history becomes geometrically more expensive.
You mentioned MCP servers earlier. How much weight do those actually add?
They add massive token overhead behind the scenes. Every connected server passes its entire instruction manual to Claude with every single message.
So even if you don't ask it to check Notion, it reads the Notion integration manual anyway?
Yes. 5 connected servers can add 90,000 tokens of overhead per turn.
That is insane.
You are sending a novel back and forth before you even type a single word. It drains your wallet and dilutes the AI's attention span.
It's like carrying all your past grocery lists to the store. Eventually, you can't find today's list. You need to clear the cart.
That's exactly how the attention mechanism degrades with noise. Claude gives you 2 essential commands to manage this.
Let's unpack /compact first.
Use /compact to summarize the current session. It condenses the history into core facts. It reduces the token weight significantly while keeping the project context alive.
And what about /clear?
Use /clear to wipe the memory completely. The golden rule is simple.
Which is?
A new task requires a totally new session.
Right. Because if you don't clear the context, you fall into the correction loop trap.
This is a nasty hallucination spiral. Claude tries to fix a bug, but it breaks something else.
Yeah.
Then it tries to fix the new bug and panics. It just burns through your tokens rapidly.
We need to pause here. 2-sec silence. The source mentions a file system access risk. Giving an AI direct terminal access feels like a massive security vector.
It absolutely is.
Yeah.
The agent has your local credentials.
Wow.
It can execute scripts natively. You must never run autonomous mode on a production environment. You always isolate its work on a separate Git branch.
How do you break out of a correction loop?
Stop, use /clear, and ask for a plan first.
So if you manage the context well and keep those guardrails up, you unlock the final stage. You move from building features to automating your entire workflow.
This is where the paradigm truly shifts. We are looking at skills, hooks, and routines.
Okay.
They codify your logic into automated systems.
Let's explore skills first.
Skills are reusable, executable workflows. You define a complex process once.
Like a mandatory security review checklist before every merge.
Exactly. You tune your brain's logic into a callable function.
Nice.
You just invoke the skill instead of typing out the instructions again. It's brilliant for standardizing testing protocols.
Next, we have hooks. These sound like the guardrails you might forget to enforce yourself.
That's a great description. Hooks are automatic actions triggered by specific system events.
Give me an example.
You can tell the system to run your test suite automatically after every single file edit.
Wow.
It intercepts failures before you even notice them.
And finally, routines.
Routines handle scheduled maintenance. Think about generating a daily summary of open GitHub issues.
Right.
Or running silent dependency checks every Monday morning.
The source notes it can even handle deployment.
Yes. It can string together the build commands, handle the authentication, and upload the files.
Just like that.
It can deploy your local app to Vercel with one simple command. It hands you back a live, shareable URL instantly.
This changes the developer's role entirely. You aren't writing every line anymore. You are managing a system of automated workers.
You essentially become the technical director. The agent handles the tedious syntax and boilerplate. You focus your energy on architecture, security, and user experience. It's a massive multiplier for your time.
Can a routine run without any human input?
Yes, it runs on a schedule for recurring maintenance tasks.
That brings us to the end of our deep dive today. Claude Code clearly isn't just a fancy autocomplete. It's a highly capable, dedicated teammate.
It really is. But you have to master the foundational rules first.
Right.
You must onboard it properly with a concise CLAUDE.md file. You always demand a solid architectural plan before it writes code.
You also have to keep the context memory incredibly light. You rely on small, easily reviewable diffs to maintain absolute control.
Exactly.
That is how you safely unlock its true potential.
Yeah. The best way to learn is by doing. Try building a small project using the exact build loop we discussed today. Give it a clear task, review the output critically, and iterate visually. You'll quickly see how it changes your workflow.
Thank you for joining us on this deep dive. We hope this helps you build faster and manage your automated systems smarter.
It's been a truly fascinating conversation.
Before we go, consider this. If Claude Code can schedule its own routines, run its own tests, and deploy its own fixes, at what point does the code base belong to the agent and you just become its manager?